Hello guys, so let's discuss today's POTD, and that is 3350. It is marked as medium. So the problem says that given an array nums of n integers, your task is to find the maximum value of k, for which there exist two adjacent subarrays of length k each, such that both subarrays are strictly increasing. So this is the a medium version of yesterday's POTD. We have to do the same thing as we are doing in the yesterday's POTD, but in a optimal way. And we have to return the length of the strictly increasing subarray. In yesterday's POTD, we are returning whether there exists any subarray, this type of subarray or not. So we were returning the Boolean thing. So we have to return the maximum possible value of k, and we have to check whether there exist two adjacent subarrays which are strictly increasing. So these are the example test cases, and the constraints are high for this problem. So we have to write an optimal solution for this. So I think there's no need to to explain this example test cases. So we should move to the solution part. So after reading this problem and after doing the previous problem, means yesterday's POTD, so the first thing or the first observation you can say is that the longest, if there is an longest increasing subarray present in this array, and if it is even, or if it is odd also, then we should divide it by 2 and our answer can be this. Suppose let's understand it with this example. Suppose 2, 3, 4, 5, 6. 1, 2, 3. This is our array. So the longest increasing subarray is this 2, 3, 4, 5, 6. So if we will divide this length of this subarray by 2, we will get 2. So our maximum our two subarrays which are strictly increasing can be 3, 4 or 5, 6. So the length of 2 of each subarray. So our answer can be this 2. But here, as you can see, there's a better answer exists, that is 3, 4, 5, 6, and 1, 2, 3. So length 3 subarray exists here. But suppose this is our array, then our two length array exist in this. Two length subarray exist in this array. So the first observation is this itself, and what I've done is I'm creating the length at each index. Means I'm storing the length at each index, that whether the previous suppose this we are currently at this index. So I'm checking whether the previous index is less than the current index element. If it is so, then I'm storing the previous length and plus 1 in the current index. Why this? Because if the current index element is greater, then it means all the previous elements are less than this the current element. Okay, so you can also understand with the by generating different test cases and doing the dry run. So this will always be true. If the current element is greater than the previous element, then the uh, length which we have stored in the previous element will we can add that length in the current itself. So I created a DP vector, and I am doing the same for this. If the current element is greater than the previous element, then the length till the previous element holds this strictly increasing part plus 1. Suppose let's understand with this example. Suppose 2, this will contain 1 because the one element is itself increasing, and now I am at index 2. I am using one based indexing. I'm at index 2, means mm, this 3 is greater than the previous element. Now I will check in my DP vector that how many element, my previous element is strictly increasing. So current, this one is for this current element, and I'm checking whether I'm checking the DP vector for the length of strictly increasing subarray previous than the current element. So this is 1, so this will become 2. Similar for this index 3, this element is greater than the previous element, so I will add 1 plus. Now I will check the length stored in the previous element, that is 2, means this 2 is this subarray is strictly increasing, so 1 plus 2, this will become 3. So this from current index to the 3 element in the previous indexes, my subarray is strictly increasing. Same for this part, this will become 4 and this will become 5. Now I will come here and I will check whether this element is greater than the previous element or not. As you can see, this is not greater than the previous element, so I will restart it from here, means this will contain my only one, which is which I have initialized in the vector itself. Now same for this 2, this will become 2, because I am just checking the till where I can make this subarray strictly increasing, or as I am checking for the previous indexes, so I can say from current index to the previous index till where I can make this array strictly decreasing. Same for this, this will become 3 and this will become 4. Now the main final part of this solution, of our solution, is now I'm checking uh, I have used different conditions here to find my answers. So the DP vector, my holding the current length. So this current length is that length that is stored in the current index of the DP vector. And now I'm checking whether my this current length, whether my current index minus current length that is stored in this vector is greater than or equal to 0. If it is so, then I'm checking whether the mm, the current index minus this current length is greater than the current element stored in the DP. If it is so, then I am updating my answer. Also, I'm doing this check with if the DP vector, means I'm doing this for this, like if 1 2 3 4, that the condition or observation I have tell you at the starting. For this I am using this check. So the main logic part or main observation is this part. So yeah, at last I'm returning my answer. So the overall time complexity for this approach is approximately order of n, because we are using O of 1 here and O of n here and O of n here, and we are using an extra space of n size for n size DP vector. So the space complexity will be order of n. I hope the solution is clear, and let me understand one more time this condition. So what I am doing is, if my current mm, index contains 3, suppose if my current index contains 3, this means that the previous 3 element or if I will select the previous indexes, means my subarray is strictly increasing. So I can take 2, I can take 1. Uh, Same here for this, I can take 1. I my previous my means the DP of I minus 1 is greater than the current element, then I can take this element as my answer. But it is not, since if I will use this 0 1 2 3 4 5 5 minus 1, if I will do 5 minus 1, I will reach here and this element is not greater than the current element, so I cannot update this answer. But for here 5, or from where I can, from this, if I am currently at this index, if I will do this check, this condition, I minus 3, means I will reach somewhere here, and if my this element, sorry, I will reach here if 0 1 2 3 4 5 6 7 7 minus 3 4 0 1 2 3 4 I will reach here, means I can take three element. Why? Because this itself is saying that the I have already have 5 length subarray which is strictly increasing, and this is saying that I have already 3 length subarray, means I can take these three and this three as my answer, means there exists this three array and this 3 length subarray, so I can take this as my answer. If you will do this dry run for some of the test cases, even if you will do for this test case, you will understand this whole part. So this is the solution for today's POTD. Thank you.